Hi everyone, in this video we're going to be continuing with Bifrost for Maya. We'll be looking at level set volumes. Level sets are a very powerful way to get complex geometry even from very simple starting points. The example I'm showing here has a level set being generated from a single sphere, and all of this complexity is developed just by mixing the original sphere geometry with some fields. And in order to be able to remix the sphere with fields, we need to turn it into a level set, which is a type of implicit surface based on a voxelization of the original geometry. That might sound a little bit complicated, but it's pretty easy to set up. And we're going to create this little model, and let's just dive into it. Okay, we have our blank Maya scene, and I'm going to go to Windows and open the Bifrost graph editor. I have mine parked here along the side with the other tabs. And for this example, I'm going to start with the Bifrost browser and go to the scatter pack scenes and load this example scatter and volume. So I'm not going to open the example scene. I'm just going to import this basic scatter and volume mini example. And this will populate our scene with a sphere. We could replace it with our own geometry just by middle mouse button dragging in a mesh if we create one. But we'll just go ahead and start with the default sphere mesh. That should be fine. And I'll just go ahead and delete that. And what we see here is the scatter and volume node scattering points inside of our sphere. And there is a fractal noise field which is assigned to the weights input of scatter and volume, and that is what's giving us the distribution of points. If I were to delete this just by selecting the wire hitting to delete, you'll see that this volume just gets completely filled with points. So I'm going to hit undo, and now I have this, this varied field. And of course I could come into the fractal noise field and play with the frequency. And if I make it larger, then I'm getting a more intricate pattern. And if I make it smaller, I'm getting a less intricate pattern. So if I go to 0.03, for example, or 0.003, I should be getting, that's in the frequency, sorry, not the ratio, 0.03, 0.02. You can see that I just get half of it filled. And as I bring this frequency up, it gets more complex. So that's how that works. And let's just start with the default, and we'll go from there. So we need to clarify a couple of things. One is that, let's turn off the terminal here. So we're just looking at the points. We're using the scatter in volume component, but that is not the volume type of volume that we're going to be making. We're going to be making a level set volume, and this scatter in volume is simply referring to volume in the generic term. Any sort of geometry that has space inside of it, we could think of that as a volume. But that's not the kind of special volume that we're going to create now, which is a level set. So to create that, we need to, let me go ahead and make Bifrost a little bit bigger. We will hit the tab key and create a points to volume. So we'll grab the points to volume node. And this is going to create our level set volume. And it will create a we'll create a charge, if you will, around, well, what it's going to do is it's going to put a voxel grid around our object. And we could probably now visualize this more easily by hitting tab and going to voxel, where is it, volume scope, and oops, volume scope, grab that. And this volume scope, now that we have a volume, points to volume, we can visualize it. And I'm going to go ahead and maybe turn off our points representation here and plug this in, points to volume. And then if we look at our detail size, I think 0.05. Let me just raise this up to 0.5. Also, you know what? I'm going to change this to, well, let's just Yes, let's change this to 0.5. We're in absolute mode, and we can talk about what that means. And I'm just going to toss this volume scope into our terminal proxy and visualize it. And let's see what we get. Okay, and so what we see here, it's a bit difficult to see because it's so dense, but I have a series of cubes around my object, and the density of these cubes will determine the threshold at which we create a, with which we can create surfaces around our volume. If we make this in the points to volume in the absolute mode larger, so we've got 0.5. If we change this to 2, for example, we have much larger squares. And if we shrink this down slowly, you can see that we get many more cubes. And this will allow us to sample our points at a finer degree of detail. Now, there are two modes here, and we have to be careful with them. Absolute mode will set whatever detail size we set here will be corresponding to the units in our scene. So typically that's centimeters for Maya, and so if we hit our detail size, that should be 1 centimeter. In fact, if I just make a mesh box here, we should be able to confirm that and bring that over. And let's see here if they match up. They may or may not. Let me see here. It looks like our detail set size is maybe gets 4 of these cubes, something like that. And then if we take it down, we could kind of match this. But it should relate to our world units in some way. Oops, I didn't mean to delete our volume. Let's get that back. I just meant to delete our cube. Get rid of that. All right, but there's another mode that we can use. And if we come to the volume scope, and this is what, I'm sorry, our points to volume. There's also relative mode. And relative mode is another way of setting the size, but it's a little bit more forgiving, I think. It's very easy with the absolute mode, with a very, very small number, to get a very slow volume. And if you set the number too low, then it can crash your computer. So be careful with this, and maybe start with relative. And the one thing you should never do is set the detail size in relative and then swap to absolute, because this will typically be way too low of a number, and it could get really laggy and maybe crash your machine. So let's stay in relative mode, and let's see what kind of detail size we need. But this gives you some representation of how the level set is being sampled from our with voxels. So I'm going to turn this off. Points to volume. Let's come back to the points to volume node. And the first thing we need to do is click Store Level Set. There are two types of volumes that you can create with Bifrost. One is a level set, one is a fog. I haven't worked much with fog, so let's just stick with level set, because this is, I think this is what you'll typically be working with if you're working with geometry. And we can, now that we've created our points to volume, we can turn it back into a mesh. So hit Tab, and we can type volume to mesh, and let's see what we have. So volume to mesh, this component will give us a preview. So I'm going to pull this over into volumes, hit the P key here, and let's see what we have. And you can see that we have a pretty blobby mesh. And remember, all of this is coming from, I'll turn our scatter and volume back on. So this mesh is being generated by sampling the points that we've scattered in the volume. And so you can see that we could probably dial this down to get a finer mesh from those points. So if we come to points to volume and look at our detail size, one thing we might start doing is dialing our detail size down, and that's going to allow our level set to hug the the points, or more closely wrap the points. So that's one way that we can establish our detail size. So I'm just going to go ahead and dial our detail size into 0.015, and that seems to be pretty good here. And if we turn on our volume scope, we can see how our detail size is relating to the voxelization, right? So I'm thinking, and if we just grab our volume to mesh here and maybe turn our, what do we want to do? Points to volume. We can grab the, yeah. So you can kind of see that there are a number of squares, and those squares are being aligned with the meshing more or less with our cubes. And so this is determining our subdivision. So going back to our detail size, I want to make sure that this is in the points to volume. This is 0.15. So that seems to be pretty good. Now it's a little bit tighter, and that's looking good. I'm going to turn off our volume scope. So turn off this proxy here, and this is looking pretty good. All right, what else can we do with this? We could send this to Maya as a mesh at this point, but I want to show you a few more things that we can do with this. Let's look at our points to volume and go up to the top value, which is the offset. Once we've dialed in the detail size that we think captures a reasonable level of detail, we can attenuate that detail further. So the offset will get close to the implicit surface that's being set by the detail size, but we can also make it a little bit smaller by, say, going to -1, and let's turn off the points, the representation of the points. And so you can see that that has thinned it out a little bit. So that's -1, that's 0, and -0.5 will just shrink it a little bit. If we go back to 0, this is the baseline, and then if we want to make it larger, we could increase our offset. So we increase it to 1, and then of course if we make this as a slider, we can kind of make it blobbier and grow it out and make it puffier by making the offset value larger. So it's basically offsetting where it's sampling this imaginary surface around the points. So I'm going to set this back to 0. And go to the meshing, because the meshing is another thing that we can also change here. So if we're generally happy with this, we can also change so here we can change the offset. Here we can change the level set threshold. So here we could also shrink it a little bit. So -1 is going to shrink it down. But you can see that we get a shape that's not exactly like changing the offset here. So it keeps the same more or less form, but it starts to shrink it in and make sharper angles. And so if we go back to 0, there's this, and if we go to -0.5, it starts to shrink it in, but it shrinks it in a little bit differently than if we were changing the offset. So that's something to experiment with to get shapes that are more to your liking. And then we can also set the detail size scale here. So again, we're in the volume to mesh tab here. And this detail set scale size is talking about the mesh detail. So if we want this to be larger, we could set it to 2, and you can see that we get a lower resolution mesh. So this is really just changing the resolution of the mesh. It's not changing anything about the sampling of the level set, it's just changing how the mesh will be output. So by default, this might be 1. If we want a finer resolution mesh, we could change this down to 0.2. The adaptivity, let's see if we get varied property. Does that, oh, that's not helping anything. So we'll change this to automatic, and that's looking pretty good. And so this would be the mesh that we offset, or that we output to Maya. We can also play with the smoothing. So 0.1 by default. What if we do 0.2 or 2 or 25 even? It's not changing it a lot. So I'm just going to change it back to, what was it by default? let's see, volume to mesh 0, 0.1. Let's see if we turn off this, if we see a big difference. So smoothing, so that's 0.1, and let's change this to 0.25. That's not making a huge difference, but let's say it makes it a little nicer, so we'll keep that. And let's try to play with these values a little bit. So maybe in the points to volume, the detail size, let's volume subdivision, let's not change anything. Adaptivity, we could say optimized here. That should have some difference, might have some impact on our mesh. If we go to optimized, if we turn that off, it's not changing anything. All right, so I'll just leave it optimized here. Resolution mode relative, we're not going to change that. We can see what happens if we make it a little bigger. That makes it a little smoother if we change the detail size, so maybe we want something like that. And let's just say that this is looking pretty good, and we could smooth it out further once we send it into Maya. All right, so what more can we do with this? We can make multiple level sets from our volume. And let's do that now. Let's go ahead and, what do I want to do? I think I want to copy everything. So all of these three nodes, from volume to mesh, points to volume, scatter, and volume, we are going to Control-C, Control-V, and copy all those nodes. And they're connected to one another. And so this is giving us the exact same thing, but I want to show you how we can get the inverse of what we have now, and also how we can resample the field with an F-curve. Let's do that now. Let's first start by getting the inverse of our shape here. So let's imagine that we want a second shape that fits kind of neatly within that one, the counterpart of the rest of the sphere. We can get that by hitting Tab, Scalar Field, and we will give a value of -1. And we're going to multiply our original fractal noise field with this scalar field with a value of -1. Hit Tab, multiply, grab our noise field, put that in here. Oops, noise field, put that in there. Okay, so if that connected, then finding this plus sign, adding our noise field, or our scalar field rather, here. And let's see what happens when we now, in our copy of scatter to volume, make this the weights input. Okay, and you can see that I have now this interlocking mesh geometry. And this is where you could start playing with the offsets. So for example, if I wanted this new one to be a little bit smaller, I could make the offset -1 and start to maybe shrink that one in. So we're getting that one shrinking in a little bit. So that's something we could do if we didn't want them to be quite so tight. Tighten this to 0, we could make it blobbier. Points to volume, volume to mesh. We could also change our offset here. So our level, or I'm sorry, volume to mesh, we could set the level set threshold. We could try, pulling that in, making that a little bit smaller, just so we can read the seams between these two objects. So that's interesting. We give them different materials. The other thing we could do is we could use an F-curve to manipulate the field further. So let's do that. And what does an F-curve do? An F-curve, so let's see, let's go ahead and just reset this one back to 0, or the volume to mesh, the level set threshold, let's make that 0. So they're nesting exactly together. And we'll operate on the second one we made, so the inverse of the default. I'm going to hit Tab and use an F-curve field component. And by default, this F-curve field will be a diagonal line going from 0 to 1 upward, and this will not change anything at first. Oops, I put that in the wrong input. Let me hit undo, undo. Here we go. We want to put this into the weights. And we won't see a change, but now we can click the F curve and we can begin pulling this down. And this, you can see, is having some effect on our shape here. And by default, it is this Bezier spline. And let's pull this up and see if I can change the handles here. Make this tighter like that. Trying to manipulate this. And these are not really giving me the results that I want. So I'm going to come up here and look at the preset curves, and let's go back to a linear curve here. But now I'm going to just drag this down and make it quite small. Okay. And now you can see that it's starting to give me a lot more variation in the second one. So it's much more stranded than it was before, strandy, lots of small pieces, and it looks really different from the original one. So the F curve can really give you some interesting results. And then you can, of course, play with the F curve field value and mix that in with the offset. So let's say we like this, but we wanted to attenuate it more. We could try an offset of -1, make those strands a little bit smaller. We could play with the level set threshold, just making, once we like the shape, we could kind of make them a bit chubbier like that. And we could really play with these values to get a look that we're interested in. Okay, so that is the basis of how we can work with fields. So again, this is starting with an original sphere. It's in this example. Let's go ahead and just quickly show how we can change it. So what should I use? Maybe a polygon cone. Let's grab that and come back to the Y is up. There we go, like that. Drag this cone over, ER, and make this larger. And let's bring that over here. And I'm going to middle mouse button drag this in. So now we have our cone shape. This needs to be routed into both our scatter and volume nodes. So the way to simplify this process, I'm going to hit Tab and create a pass. And a pass is just a node that allows us to plug in additional, so it basically becomes like a little relay. So I can quickly swap things out in the future. So if I have my input plugged into this pass here and here, now I could come to my P-cone shape and plug that in. And now, now I'm getting that all of the setup, let me hide my cone. I'm getting that setup applied to my cone shape. There is one other important thing which I should talk about here before I export this. If I take my cone and move it over, there may be a point. Okay, that's not happening, which is good. Nothing's disappearing. But if I make it larger, maybe something will disappear. Well, it is changing the resolution of it, but it's not really cutting anything off, and that's good. So maybe I don't need to worry about that. I thought, however, there was a spot. That must be with a different volume to mesh. Do I have a spot where, okay, it's not with this example, but there sometimes with levels, when converting level sets, you actually have to make sure that your object is within a certain voxelization boundary, but we don't have to worry about that with this example. So this is working quite well. And then I could continue to work with my F curve here. Let's grab my F curve and bring it down further and attenuate this more with this to get it more PC, stranded, eroded in that zone. And now that's looking more varied. And let's say that I was happy with that. Bring it up just a little bit. And let's say we wanted to then bring this back into Maya. We would do that with a terminal. So tab terminal, grab our terminal, and not our terminal. We would do this with an output, tab output. Bring in our mesh, and Control C, Control V. Get another one, bring in our mesh. And let me just go ahead and Shift Control H, hide Bifrost, so you can see what happens when I right click this mesh output and create a Maya mesh. And then I'll right click and create a Maya mesh. And then I get these two meshes in Maya. And now I am, with the poly modeling tab open, going to freeze their pivot, center their pivot, delete their history, and freeze their transformations. And then I could give them assigned existing material, standard surface. Don't know why they're still blue, but if let's try assigning them a Lambert, still blue, and that is, I'm not sure where this blue property is coming from, but in the hyper, if you started making new materials and assigning the new materials in the hypershade, you can surely get rid of these materials. Let me just hit Control D and make a final copy here, or second copy. And what we could do, let's go to the, all right, so we have this pretty dense triangular mesh here. And to texture this, we should probably turn this into a quad mesh. And the way that we could do this is, first of all, just by looking at the display. Let's turn on the heads-up display and grab the poly count. And now when I select this one, I can see that this has nearly 50,000 faces, and this one has nearly 60,000 faces. We can retopologize this. Before we do this, we also would like to go to the attribute editor or the modeling toolkit and separate this. So make sure that we're grabbing all of the individual meshes. And so I can say that this one, so there were multiple disjointed meshes in that mesh coming out from Bifrost. And then each of these we could retopologize. And then once we retopologize it, we could texture. So retopologizing, we would do that under the, make sure that modeling is active here. We would go to the mesh, we would go to retopologize, look at the options, and we would do, we'd probably turn off preprocess mesh. In this case, we would look at the number of faces, so in this case 40,000, and we would want to make our target face count probably like that, maybe a little bit more, 40 or 50,000, probably 40,000 would be fine, or you could even go down if you wanted as well. You just have to experiment. Before I hit apply, it's also really good to turn on the, if we go to Windows, go to the output window, and the output window will show you the what's happening with respect to the retopologizing, because this process can take quite a long time. What you would want to do at this point is number one, hit save. So I'll save it as a new scene. Let's call it test. I already have one. Test retopo volume. Okay, I have it saved. I have my output window open, and then I can hit apply. Oops. I should be able to hit apply. Let's go to find the output window again, just make sure that's on top. And now we can hit retopologize, and it's going to start. I'm going to pause the video and I'll show you what the result is. It's still working, but I've unpaused the video just to show you how the output window works, and it's going to show you all of the steps, and so you don't get discouraged and hit escape or close Maya. It's going to show you all of the processes, and so that you know that it's still cranking. Okay, so now it's finished, and we get this nice quad mesh, which we could texture. One thing to note, though, is that once you run the retopologizing and you're happy with it, because this process can take a long time, we want to go ahead and center the pivot, delete the history, and freeze the transformations on this object. Otherwise, let's say if I were to have closed Maya before doing that, every time I open Maya again, it's going to rerun the retopologizing. And that's a real pain, especially if you're doing it run it on multiple meshes. So once you run retopologize, flatten the object, and then you can proceed with texturing it. So I hope this has been useful for you. I'll make another video in which we look at other ways of eroding volumes or eroding objects using level set volumes. Thanks for watching.